Hello again. We are still here in RStudio. I'm in the project. Mine is called Student Folder. I just opened RStudio because I closed it before, so I have to run my libraries again, so this just serves as a reminder for you as well, that every time if you closed RStudio and you open it again and you want to continue on where you left off before, you have to run your libraries again. So I have to run that and then move down to where I want to be. Another trick I can show you, since I'm now moving down here at the very bottom, you can see there's a word here. Mine says study design. If I click on this, this gives me a list of all my headings and chunks. So if you have a long document gets long and confusing, you can just find where you want to be on this list, and I want to be in chunk 5, so I can just select it there from the list. So this is where we left off last time. You were reading about the study design, and now we are at a heading that says sampling from the population in code chunk 5. So we read in this set called population set, and here is a function that I'm going to perform on the object called population set, and this function is n row. That's how you pronounce that, and so that is n is for number of, so this function is one that shows you how many rows you have in your object. So if I run that, you can see it tells me we have 100,000 rows. So obviously you could have done it with dim, which we learned before. If I set dim population set, so here's another thing that happens. You see that RStudio suggests, if I just start typing, it suggests it can do auto completion for you. So if you wanted to use that feature, you just start typing. As soon as it suggests something, you press tab on your keyboard and it completes it for you. So if I did dim, of course it would give me the same 100,000 rows, but in this case it just also tells me how many columns I have, so I could have used that as well. Just going to delete it. So if I look at what that looks like, so if I just start typing as before, it's going to suggest some things to me, and I can just move down with my arrow keys in the list of suggestions till I find the one, press tab, and then it auto completes it for me. So if I write the object name and I run only that, you can see what happened. So we have a list here of 10 numbers, or a sequence of 10 numbers. So these numbers, remember we told R to take a sequence from 1 to 100,000 and sample from there. It basically took 1 to 100,000, the numbers, put it in a bag, put its hand in 10 times, and drew out 10 samples from the bag. And so those are the numbers. These numbers are those numbers that R drew out of the bag. So that's what it's giving us. So as you can imagine, this is a random process. So that's just how the sample works. It's random. It samples randomly. We don't guide it in any way. It's like putting your hand into a bag and drawing numbers out. So the question is, if I run this again, am I going to get the same numbers? And again, as you can imagine, if you throw back these numbers into the bag in real life now and put your hand back in and draw them out again, the chance that you're going to get exactly the same 10 numbers are small. And so in R it works like that as well. If it's going to randomly sample, the chance that you're going to get exactly the same 10 numbers again, if you sample again, is small. But in analysis, in data analysis, we make mistakes many times. So many times we run the same code over and over again. So we need to be able to get the same sample again. So the first time we sample, we want that to be random. But after that, if we made a mistake and we have to run the same code again, we can't have it taking a different sample every time, except if that's what we want. But in this case, for example, that's not what we want. We want it to stay consistent now after this. And that's where this set seed function comes in. So it's like a set seed is the seed is basically a place. So it's I'm not going to explain how exactly R does it, but it's basically a place where R starts searching or whatever, however you want to think about it. So if I set the seed to 100 and then I take a random sample, then that's like a placeholder for R. So that if I want to do it again and I want exactly the same 10 numbers again, then I have to run set seed 100 again. And then I will get the same sample. I'll demonstrate this just now. If I change the seed to something else, 400 like here, or 700, it doesn't matter what this number is, it must just be a number, then I will get a different sample. And that's what we're gonna demonstrate here. We'll get to this line of code just now. For now, I'm just going to demonstrate this. So I still haven't run set seed. I just want to demonstrate to you that if I run this again, I'm going to get different numbers. What I also have to demonstrate is, so we said before, we give a thing a name, like this, sample1_rows. We assign it, and then we run something. And so whatever the result of this is gets saved in this name. So if you run that code only once, then you have no problem, because as we saw when we ran this, like here, we get the sequence of numbers, and that's what we expect. But R will overwrite something. So if I run this again, it works like on your computer. When you're typing a Word document and you save it as my document, then if there's no file in the folder where you're saving it, that is called My Document, then you have no problem. Word will save it. But if there's already, the next time, maybe you're writing a different document, and now you say save, and you say you want to save it as My Document, then Word is going to tell you, do you want to overwrite the document because it already exists. There's already a document called My Document. Now this new one, do you want to overwrite the other one? So that means this document is going to replace the other one. So R works like that as well. So the only difference is R isn't going to ask you. Like Word is very nice and it's trying to protect you from losing your file. So it's going to ask you, do you want to overwrite? R is not going to ask you whether you want to overwrite. It will just do it. So you have to be aware of it. So we already ran this code. So we already have an object called sample1 rows. So if I run this line of code again, it's going to change this object without telling me. It's just going to change it to the new thing. So I'm going to do that. So see, nothing happened. It didn't warn me or anything. It just did what I asked it to do. And now you'll see if we run this object, the name, you see we get 10 numbers again, because that's what we asked for. But as you can see, it's different numbers. So that's what I was talking about. R is going to, every time I say sample from a sequence of 1 to 100,000, R is going to take a random sample. And it's going to be a different one every time, even though the code stays the same. Because it's a random process, it works like putting your hand into a bag and drawing out marbles or numbers. It's going to change every time, as you can see here. So now I can't get this sequence back, basically, because I don't know where we started. I didn't run this set seed, so I don't know what the placeholder was that R used, or not the placeholder, kind of like just a mark for itself or whatever to start the random process at. So I can never get this sequence back, basically, because I didn't set a seed, so I can't reproduce the random process that R used, and also I wrote over this object by running this line again. So sample1 rows now is this sequence. It's not this sequence anymore. So that is why we need a strategy. That if what we wanted to do was to get this sequence again, we would have to follow a strategy to make that possible. So that's what I'm going to demonstrate now. So if I run set seed 100, nothing happens, and that's what we expect. We're not expecting anything to happen. Now I run this code again, so for the third time I overwrite it, and this sample rows object is now yet again a third sequence of 10 numbers. And if I run it, you'll see it's now again, it's different from that sequence and from that sequence. It's now a completely different sequence again. But the difference this time is that I can get this again. So if I run this again now, without running set seed again, you'll see I get a completely different sequence of numbers. Again, because it was a random process. But if right before I do it, I run set seed again, and it's 100, still the same number in there. Now I run this again, and now you'll see that this was the one where I ran set seed, and then I sampled, and then I got this sequence. And you can check there for yourself. The sequence I got just now is the same as that one. So that's just a strategy in R. This is not statistics or anything. This is just a strategy for if we're going to do this thing of taking specific samples we are from a sequence of numbers. To be able to reproduce it again, you have to run set seed right before you run this sample function. So you can now so why are we taking the sample in the first place? So let's explain this line of code. So we're taking this sample of rows in the first place because we have this big data set called population set. We said it has 100,000 rows, so that's why we used 100,000 here. But what we want to do eventually for each one of you in the class is we want to take a sample of 400 people from this population. So each one of you are going to go forward with your assignment with just 400 people. And so in order to take those 400 people from this population set, we're not all just going to say, well, let's take the first 400. We don't want to do that. We don't want you all to have exactly the same data set. We want you all to have a different data set. And to achieve that, we're going to take a sample from this big set, not of 10 like in this line of code, but of 400 eventually. That code is lower down. But so how we're going to handle that process is we're going to take a random sample of 400. So each one of you are going to take a random sample of 400 from this whole population set. And that's why we're going through this whole exercise. So that's what I'm demonstrating here. This is not the final 400 sample that we're taking. I'm just demonstrating it with a smaller sample. So again, we're giving it a name because whatever this function is doing, we want to save it in an object. So over here, I'm just calling it sample1. Then over here now, I'm just using population set. That's an object. It's not a function. It's an object. And as you can see, these are not round brackets. These are now square brackets. So as I said before, round brackets and square brackets do completely different things. Round brackets and square brackets do completely different things in R. So in this case, we have the population set. That's the object, the data set, the big one with the 100,000 rows we're talking about, followed by the square brackets. And then inside the square brackets, you see this object, which is the one we just created. And since we ran it, we actually know what it is. So we know that this object, this name of the object, is just a placeholder actually for 10 numbers. So it's as if we're putting these 10 numbers in there, because R knows that this name is actually, it's just a placeholder for these 10 numbers. So if I put that, if we put sample1 rows in here, that just means R is reading these 10 numbers. Is going in here. And where we saw square brackets before, like this, was when we were looking at a specific row or a specific column of a data set. So that's what's happening here again. And as we said before, rows always first, columns second, separated by a comma. And as before, the previous time we saw this, there was nothing in front of the comma, but there was a number behind the comma. And now it's the other way around. We've got some numbers before the comma, because I said this is just a placeholder for 10 numbers. And then after the comma, we have nothing. So that tells R that if there's nothing behind the comma, it says we want all the columns of this population set object, because remember it has many columns. So we want all the columns, but we only want 10 of the rows, and these are the 10 rows that we want, these numbers. So these numbers are now the numbers of rows, not the numbers of rows, the row numbers, sorry. So with this first one, it's 82,423, so R is going to go down that whole population set down the 100,000 rows, and it's going to go to row number 82,423, and it's now going to select that row only and save it in sample 1. But not that row only, each of these. So it's going to go to each of these 10 rows, select it, and put it into this sample 1 object. So if I run this, and we just look at the object we created, you're going to see there it is. It's a data set, and it's got all the columns that population set has, and it's showing us 10 rows. It only has 10 rows. Of course, if it had more than 10 rows, it would have showed us the first 10 rows and just told us there are more rows. But as you can see now, the IDs happen to be, in this data set, happens to also be the row numbers. So that makes it convenient, so you can see that indeed that is what R did. It went to 82,423, chose it, and so on. You can see those are the same numbers. Okay, so that's what that does. So what you should now do is run the rest of this code, chunk, and do what I did now. See what happens. You're going to set seed. So what happens if the seed is different? So over here you'll see this function is exactly the same as that function. It's exactly the same function, exactly the same numbers. Sorry, these are not corrected yet. It's all exactly the same function. We're saving it in different names. So we're creating 4 different objects, and then we're doing the same, and the seeds are also different. Although over here it's the same again. And then over here we're doing the same thing that we just did. We're just giving it a different name. We're calling it sample 2, sample 3, sample 4. So what you have to do is run this code, and then eventually over here I have this $ID, so I'm basically just running you're just going to run this first column of the data sets, the different data sets that you created, and that's just so that you can compare whether R chose the same for every sample or different ones, or maybe some of them are the same, and then I want you to understand why they are the same or why they are different. So that's what you can do now.